to 21, maybe most of you will be having your exams.
So it will start probably from 15th July.
Yeah,
15th July, so exams will be starting.
15th. Yeah, mostly that is the day 15th, 18th. Some of them may
So
be starting
12th,
from 15th, some will start 12 also. Okay. So first of all, see if the screen is visible to you all. Is the screen visible to you all?
It is black, sir.
Okay. Yeah, it's black. Okay, Pranav. That's a new thing. So let's start writing about. Now we are going to do fluid friction. Okay. So what is fluid friction? Do fluids also offer friction?
friction in the liquids.
Yeah, not only liquids. When we say fluids, the substances that can flow. Yes, so which are the substances that can flow?
Sir, gas and water.
Yes.
Like
So
gas.
friction due to gases and liquids. So friction due to gases and liquids is called fluid friction. So we know that all fluids, they offer a backward dragging force. So whenever an object tends to move in a fluid offers a backward dragging force. This dragging force is observed for the kite. Kites also provide a backward dragging force. So the backward dragging force is offered by fluids. So we define here the backward dragging force offered by fluids when there is a when there is a relative motion between the fluid. Whenever there is a relative motion between fluid and the substance, between fluid and substance, so will be a backward dragging force. Whatever substance is trying to move through the fluid, so that substance will experience so backward dragging force offered by fluids when there is a relative motion between fluid and substance. Then we have that frictional force or that backward dragging force is called as fluid friction. So we either call it drag, we also call it as drag, or we also call it as fluid friction. So drag and fluid friction, they are same terms, similar terms. So if you have a substance that is moving through a fluid, for example, we are driving. So when we are driving, can I does the air offer any friction? Is there any friction offered by air?
Atmospheric pressure.
No, sir.
Is there any friction offered? No. Air doesn't offer any friction.
Yes, sir, it will. It
It
will.
offers, sir.
Atmospheric
It
pressure.
offers, sir.
Atmosphere pressure.
Not the atmospheric pressure. See what happens when you try to move through air. So air offers you resistance.
Yes,
How
sir.
does the air offer you resistance? So suppose you are driving your vehicle over here on the road. So when the vehicle starts to move, it has to move through air. So the layers of air, they do not allow the vehicle to move ahead. Something like so. If the vehicle is moving, so the layers of air, it has to cut through the layers of air and then move. So in this way, air offers a friction which we call as the fluid friction, or this is the backward dragging force by the air. And this is the reason we have why the cars have flat design. The reason why cars have a flat design and buses have a vertical design. Have you seen the design of
Yes, sir.
buses and trucks is different from that of the cars. So for the buses and trucks, you
Yeah.
have the design something like this, or you have almost a flat design. But for the cars, you have a flat design. The reason is that cars have to move at higher speeds. So there will be large amount of backward dragging force by air. Also, if you observe the design of the maglev train, all of you must have seen the design for a maglev train. So for the maglev train also, we have the design something like this. Over there also the design is aerodynamic. We call this design an aerodynamic design, something like this. So that it is able to cut through the air easily. Air does not offer, uh, air should not offer it much of the resistance. Okay. So as we have seen that we can decrease or increase the friction. There are different methods of increasing and decreasing friction. So here also we have different methods of decreasing friction. So can you think of any methods by which we can decrease friction, decrease fluid friction?
Sir, by keeping a smooth surface.
Uh, Taking a smooth surface, okay, and but that doesn't work much over here. Of course, you have to take a smooth surface. There is something by having a specific design, the design of the vehicle.
Sir,
Yes.
design of the vehicle should be flat structure, sir. Flat.
Okay. Uh,
Car should be thin, sir. Slim.
yeah, their
Sir,
shape should be
lubrication.
aerodynamic. We call this
Sir,
as an aerodynamic shape, or we also call it, there is another shape. I'll just tell you the name of the
sir,
shape that is
lubrication.
there. So all the aeroplanes, submarines, they also follow the same shape. The shape of the aeroplane, it's also the same. So it also has an aerodynamic shape, something like this, so that it is able to cut through the air. Similarly, similar is the shape for submarines. So for aeroplanes, shape of the aeroplanes, shape of submarines, they are designed in such a shape. They are provided such a shape so that there is a very less resistance from air and water. In the similar way, if you observe the shape of fishes, shape of fish, then shapes of birds. So can I say that all their bodies, they are designed in such a way so as to reduce the friction due to air. So all of them, they move or they travel in such a way, their body is designed in such a way that they decrease the friction due to air. Got it? So all the fluids, they offer fluid friction when there is a relative motion between the fluid and the substance. So then there is a fluid friction. And to decrease fluid friction, the different steps, the most common step is that you have to check for an aerodynamic shape. Your shape has to be something slim. That's aerodynamics. Got it? Now let us see.
Sir, will lubricating come under the reducing friction of fluid friction?
Pardon again.
Sir, will means lubricating come?
Yeah,
Lubricating to
is
reduce
also a
fluid
part of fluid friction. Yes, yes. Lubricating is part of fluid friction. So lubricating is a part of the fluid friction. When we lubricate, we are applying fluid friction. And also, fluid friction is less than the static and the kinematic. Fluid friction is less than the sliding friction. Okay, so that is why we try to convert our solid friction into fluid friction by using lubricating oil as the substance for lubricating or reducing the friction. So yeah, for the fluid friction, the rulers we have done. Yeah. See, the last topic we are doing here, fluid friction. So fluid friction, as we suggest, it is the shape, it is the friction offered by the fluids. So the shape of aeroplanes, the shape of birds, they all have similar shapes. And this shape of their body, it helps them. Their body is designed in such a way to reduce friction. Now let's say, is there any other doubt from this chapter? I think we have completed everything from this chapter. So is there any doubt that's coming from this chapter? Yes, any doubt from this chapter?
No, sir.
No, sir.
Okay. So let's start with the questions now. Okay, see. Everyone, now be active. Maybe I will not be able to recall everyone's name, but yes, all those whose cameras are on, they will be visible first. So I'll be calling on their names, or if you know the answers, you should start telling the answers over here. Okay. So just 1 minute. This is page 9. Again, see these terms also. What are ball bearings? Who will explain what are ball bearings?
Sir, they use rolling friction.
They use rolling friction. It is a what? But actually, can anyone define what is ball bearings?
Sir, means it reduces the friction.
Sir,
They are
there,
used to reduce friction. That is also correct. But can
sir,
anyone
there,
explain me? Yes.
sir, there are number of balls between two iron rings. So when they rotate, because of the circular structure, they'll be rotated itself. So more friction won't be created. It is used to reduce
Yes.
friction, sir.
Yes. Very good, Gautam. So ball bearing, it is a set of two rings and metal balls which are fitted together. So they are fit. The metal balls, they are fitted in between the rings. so that whenever the metal there is a relative motion between the between the rings, the metal balls start rolling so that they reduce friction. Okay. So everyone has seen about the everyone has seen the ball bearings, how they work.
So can you repeat? Can you
Yes,
repeat
sir.
the thing again?
Okay, so just I am writing the answer for what is ball bearings, and I will also show you what are ball bearings actually. Okay.
Okay,
So
sir.
ball bearings. It is a set of two rings, centric rings, and metal balls fitted between the rings. Just hold on for 1 minute. Hello. Uh, okay. So it is a set of centric balls fitted between the rings. The metal balls, they are fitted between the rings. Okay. And how does it work? When there is relative motion between when there is relative motion between rings, then balls start rolling to reduce friction. See, we have seen that the rolling friction is less than the sliding friction. So during the ball bearings, in the ball bearings, what happens? In the ball bearings, when it is a set of two rings, so in those there is a relative motion between the rings. So one of the ring
So what does ball bearing commander?
about the ball bearings only.
No, which friction? Which type of friction?
It rolling friction.
Sir, you may show the ball
It converts it converts sliding friction to rolling friction.
Sir, you may show the ball bearing.
Yes.
Sir, you may show the ball bearings.
Yeah, I'm showing it.
Yes.
Just I'm showing here ball bearings. See, these are ball bearings. You have here two rings.
Yes, sir.
Yes. So if one of the rings starts moving, suppose the outer ring starts moving, so what will happen? The ball will start rolling on it.
Yes,
Okay.
sir.
The outer ring will make the balls roll along it. So if there were no metal balls, suppose if there were no balls inside it and there were only these two rings, so there would have been static friction between the two balls. Okay. So we would have observed the static friction, see something like this. It's a lot. Just let me show you some. If the outer ring starts moving, so the balls they also start rolling. Not this one. I'll show you some other where.
Sir, keep the second one, sir.
Just 1 minute. No, second one is not. Let me show something. This is the only one available. Let me see if anything else. Uh, no, this is also okay. You can try out to search, but I think you have understood that how these ball bearings are working. When the outer ring starts moving, so the balls they start rolling along with it, and when they roll, they are actually reducing the friction between the two rings. If there were no ring, if there were no balls between them, or suppose you had no balls between them, okay, so in that case what would happen if there were no balls in between them and you place the two rings together? So will it be easy for them to move? If you just place the two rings together, so will it be easy for them to move?
No, sir. No.
No. Okay, so then it will not be easy for the ball bearings to move, hence the ball bearings are used. So have you seen anywhere ball bearings?
In a
Sir,
spinner,
in sir,
Okay,
fidget
your ball
spinner.
bearings,
Sir,
they
fidget
are used.
spinner.
Yeah, in the
Sir,
fidget spinners,
skates. Sir, skating
yeah,
shoes.
in skating shoes, they are also used in bicycles. So ball bearings, they are attached something like this.
sir, the
In this
bell,
picture, you
sir,
can better
cycle
understand.
bell.
Yeah, this one. You can see here, this one. The outer ring, is moving, the inner ring is not moving. And when the ring is moving, along with the outer ring, the balls which are in between them, they are also rolling. The balls are rolling, they are not sliding, they are rolling. So here we have actually converted the kind here we have converted our sliding friction into rolling friction. Everyone has understood what are ball bearings?
Yes, sir.
Yes, sir.
Yes. Yeah, so in this way you have them in the fidget spinners, you have them in cycles, you have them wherever you require motion between two objects. They are also attached in fan. Okay.
Sir, I used to have a 2-3 ball bearings, sir.
Okay. So now see this other definition. The next is drag. So what is drag?
Pulling something.
The drag
No.
means
Sir, pulling, sir, drag, like pulling
Drag
towards our side.
sir, it means
Yeah, pulling towards our side.
it acts upon the fluids, sir. Fluids in the air.
Okay.
Sir, pulling it backwards, sir.
Pulling it backward. Okay. So drag is like pulling it backward. It is a force that pulls a substance backward. Force that pulls a substance backward, we call it as drag. Got it? Then what is fluid friction? Yeah, what is fluid friction?
Sir, friction caused by the gas and
Sir,
liquids.
friction itself caused by the gases and liquids.
Yeah, friction caused by
Sir,
gases and
caused by
liquids.
gas and liquids, sir.
Yeah. The next one is interlocking. What are interlockings?
Sir means interlocking the things.
Sir, for safety locking, sir, like the locking system in the fridge and in the cars.
Yeah, obviously there are there, but with this chapter friction, have you ever
Sir,
studied
can
this
you
chapter?
explain static friction once?
You had studied interlocking when we were studying initially about the friction and static friction. So when we initially observe about friction and static friction, so we observed that you have two surfaces. Okay. And these two surfaces, they are rough. So the irregularities or interlockings of the surface, they get interlocked with each other and hence cause friction. So cause of friction is due to the interlocking between the surfaces. Lubricants. Lubricants are the fluids which are applied to decrease friction. They are generally oily in nature. They are called lubricants. For example, mobile oil, which we use in vehicles, grease, which we use in vehicles, they are all lubricants. Then rolling friction, when one surface rolls over the other, the frictional force offered is called as rolling friction. Sliding friction, when one object slides or tends to slide over another, we call it as the sliding friction. Charantaj, what will be the static friction?
Sir, static friction means the moment, means when we mean it.
Sir, can you explain static friction once?
Sir, means when we try to move an object when it's stationary.
Static friction, when an object is stationary,
We
okay,
try to move it.
yeah, we try to move it. So the frictional force offered by a stationary object is the static friction.
So, can you write the definition down, please?
Okay. So static friction. Friction offered by an object when it is stationary or when it's not moving. So that friction we call as the static friction. Okay, anything else? Shrestha, anything? Any problem?
No, sir. Thank you.
Gagana,
Yes,
Sai
sir.
Karthik? Yeah,
All
any
clear.
problem, Gagana?
All clear, sir.
All clear, okay. So all the definitions are clear. Now for the questions, be ready with the questions. The first question is friction opposes the dash between the surfaces.
The motion.
So you will be
Motion, sir.
asking. So you will be asking us, sir.
Yeah.
So like you will be calling the names of us.
So let's see. Friction opposes the dash between the surface in contact with each other.
Motion, sir.
Yeah, friction opposes the motion between the surfaces in contact with each other. So at this, we'll be filling out motion. Okay. Then what will come next to it? Friction depends on the. What does it depend
Nature
about?
of the surface.
It depends on the, you can write here roughness of the surface, or you can write here nature of the surface. The best word over here is nature of the surface. Okay. So friction depends on the nature of the surfaces. Then this one,
Produces heat.
Sir,
friction produces.
Heat.
Sir, could you little bit scroll up?
Okay, you want me to scroll up? Yeah. So next one, friction produces. So here friction produces heat, or friction causes heat between the two surfaces. Then D, sprinkling of powder on the carom board.
Reduces friction.
Yeah. Sprinkling of powder on the carom board reduces friction. Then sliding friction age.
The movement will be fast, right, sir?
sir,
When we keep the striker on the carom board, and when we hit it with the force, it goes fast, right, sir? So it reduces only, sir. Like the fastest will be increasing.
Reduces friction. Friction means your opposing force is reduced. The opposing force is reduced.
Okay. Sir, sliding friction is lesser than the static friction.
Yes, the next one is sliding friction is less than the static friction. I'm not getting answers for. Okay, everyone be silent now. I'll be calling out the names since some of you are not answering. Amatur Rahman. Amatur. Yeah, Amatur. Sai Karthik. Sai Karthik, ready? Karthik, are you there? Sai Karthik, are you there? Okay, I will just be posting out their names in the group since they are not responding. Varshit. Varshit.
Yes, sir.
Okay. So can you answer second question?
Sir, can you tell the second question, sir?
Yeah, it's here on the screen.
Sir,
Four
like I have
children. Okay, what do you have?
internet problems, sir. So that's why I'm not able to see a screen. It's clear for me.
Okay, you are not able to see the screen. Is there anyone else also who is having a problem with not able to see the screen?
no,
Anyone?
No, sir.
Okay.
No.
Yeah. So for the second question you have, 4 children were asked to arrange forces due to rolling, static and sliding frictions in a descending order. Their arrangements are given below. Choose the correct arrangement. So out of these 4 arrangements, you are given, you have to arrange them in the decreasing order of their friction.
Sir,
So out,
sliding and
yes,
static sliding and rolling.
so static
okay,
sliding, C1, sir.
See, sir.
okay. Static friction is maximum. Then we have sliding friction and then we have rolling friction. Okay. So students, if any is facing any internet issue, do inform in your group. You have a support group. Okay. So in that support group, do inform. If anyone's mic not working or anything, do inform over there before the class. Okay. Otherwise, if suppose I call you and you do not respond, so I will be typing your name in the group, and that doesn't look good. So here, for the third question, Alida runs her toy car on dry marble floor, wet marble floor, newspaper and towel spread on the floor. The force of friction acting on the car on different surfaces in increasing order will be.
C,
So
sir.
where will,
C.
C, sir.
Sir, C, sir. C.
okay,
C, sir.
it will be
C.
maximum
C,
on the
sir.
towel. Yes.
C, sir.
Okay, is it C only? See, you have to arrange them in the increasing
Sir,
order.
D, sir.
C, sir.
C, sir.
How say?
Sir, sorry, sir. A. It's A.
A, sir.
Wet marble, dry marble floor, and newspaper and towel, sir.
Sir, it's A, sir. Wet marble.
A, sir.
So first read the question carefully. It's A. Okay. Wet marble floor, dry marble floor, newspaper and towel. So towel
A,
has the
sir.
maximum friction.
A, sir. Wet
Then
marble.
suppose for question 4, suppose your writing desk is tilted a little. A book kept on it starts sliding down. Show that the direction of frictional force acting on it. Show the direction of frictional force acting on it. So in which direction
Down, sir. Down.
will
Sir,
the
upward,
friction?
sir. Sir, upward, sir.
See, this is your table which is a little bit tilted. Something like this. Let me draw it again.
Sir,
So
to the
this is your
side it
floor.
is tilted.
It's tilted like this, and you have a book over here. So the book starts sliding down. So in which direction will your force of friction?
Upward, sir.
Upward.
Upward.
So the force of friction always act opposite to the direction of motion. So force of friction will act upward. Okay. Understood, everyone?
Yes, sir.
Okay. So bye all of you. See you again tomorrow. This chapter is completed. Try to do the NCERT questions.
Sir,
Okay, sir.
this week do we have the subjective test for fixing?
Yeah. In this, I don't know about. Haven't you got any message in the group?
Sir, this time we have microorganisms.
This time you have.
Microorganisms.
Okay. So you must be getting in whatever you get in your group. That will be the test. Okay. Bye all of you.
Yes.
Thank
Bye,
you, sir.
thanks, sir.